Guys, welcome to this video. I talk about the wind bills in the world. I've already seen the concept of wind. We've seen the types of wind or air movements. We've said that there are two of them that are sea and the land breeze. So let's see the wind bills of the world. Here we start to see the blowing of wind on Earth before seeing the bells of wind on our Earth. Now, blowing of wind on our Earth, we have to know that when the Earth's surface, the regions of the north and the south poles are very cold and have high pressure, while the belt along the equator is very hot and it has low pressure. Now, this makes air move from the poles toward the equator. The equatorial belt rising air is replaced by air moving in from the north and the south of the equator. Also, we should then expect two belts uh, of wind blowing towards the equator, but this is not exactly so because the earth rotates from the west to east and the air or water moving freely in any direction over the Earth's surface is turned or deflected to the right of its course in the northern hemisphere and to the left in the southern hemisphere. Therefore, any winds blowing from the north towards the equator in the northern hemisphere will blow from the northeast and not from the north. And any winds blowing from the south towards the equator in the southern hemisphere will blow from the southeast and not from the due south. Now, this can be illustrated as we can see that uh, showing the winds blowing from northeast and the southeast. As you can see, there is the deflection of winds as the since the earth rotates, and you can see there is uh, lining of equator that is 0 degrees and 30 degrees north and south. So the winds needs to be deflected at the lines of equator since the earth rotates. Now, from this concept, let's see the wind belts of the world. Now, in the equatorial belt of low pressure between 5 degrees north and the 5 degrees south latitudes, intense solar heating causes the moist air to rise in belt convection columns. Now, this belt is called the doldrums or the low pressure belt. And the rising air splits out or moves towards the poles. Now, in so doing, it cools and thus it contracts and it develops high pressure. Now, this occurs around this 30 degrees north and the 30 degrees south. Thus, the air sinks and builds up high pressure at these latitudes, which I've said before, 30 degrees north and 30 degrees south. Now, these latitudes are what we call the host latitudes or subtropical high pressure cells. Now, in latitudes 30 degrees north and the 30 degrees south of the high pressure air moves over the surface towards the equator as the northeast and the southeast trade winds. Now, some moves over the earth towards the poles as this west rise. Now, in each hemisphere, we have to know that there are three wind systems which operate between the indicated latitudes. These include as follows. The first one that is the polar wind system that is between the North Pole and uh, between the South Pole, 60 degrees north and the 60 degrees south. The tropical wind system that is between 30 degrees north and the 60 degrees north and the 30 degrees south and the 60 degrees south. And the equatorial wind system that is between 30 degrees north and the 30 degrees south. All this can be illustrated as follows as wind belts of the world. As we can see there is a illustration of how winds move or blow in the various places of our world. So I hope it's clear. We've seen all of these. We've discussed each one of them is high pressure building up in the uh, uh, North Pole and the South Pole, and in such the wind blows and it causes the movement of wind. And there is also these belts that are there that are the doldrums and the others which are allocated as in degrees, 60 degrees north, uh, equal to 60 degrees south, and the 30 degrees south equal to 30 degrees north, which are host latitudes, and the equatorial low pressure belt that is also described as doldrums. Now let's see the measurements of winds. Now windy direction, you have to know that it is measured by wind vane or wind sock. Specifically, this wind vane consists of a freely rotating arm that is fitted over a central rod. Now the arrow of the wind vane always points in the direction from which the wind blows, and the wind is named after this direction. Now also there are four arms marking the direction of the cardinal points that are fixed to its stationary central rod. Windy sock consists of a sock-like sheet of cloth that is fitted to top of a tall wooden or metal bar, just like the flag is fitted to the flag post. Now, the tail of the sock points away from the direction of the wind, and the direction of wind is named after the head of the sock. Now, mainly these wind socks are used to show wind directions at the airports and airstrips in order to direct these pilots when you're landing or taking off. Now, these are just diagrams that show these two which I've discussed, which measure wind direction. Wind van, as you can see there, and the wind sock. So all these are used to measure the direction of wind. Now, wind speed is also a criteria when measuring the wind. Wind speed, it is measured by an instrument that is called the anemometer. Now, this instrument consists of three or four horizontal arms that are pivoted on a vertical shaft. Now, the metal caps are fixed to the end of the arms so that when there is a wind, the arms rotate. Now, this movement operates a meter which records the speed of wind in kilometers per hour. Now, this is just of a diagram that illustrates the uh, anemometer, which is an instrument that is used to measure the wind speed. As you can see, it has various parts: the caps, the arms, vertical bar, and there's a meter that measures. So, if the wind blows, these caps rotate, and in the rotation of these caps, uh, they indicate some kind of a reading in a meter that shows the speed of wind. So that's all for this video. I hope it's clear, guys. We've seen various word bits that we have, specifically the uh, wind belts that we have on our word. Then we have discussed the measurement of wind. So I hope it's clear. We've finished talking about this wind as an element of weather. So we'll cover more on the other elements of weather in our next videos. Thank you.